So in our board meetings, we always, as I mentioned before, we rely on our board to help us identify topics for discussion. And probably 4 years ago, we did one on the ethics of AI. And then a year or two later, we ran a panel on securing AI and AI for security. And then but in this last year, when our board suggested, you guys are doing so much in the area of AI application to cybersecurity, you should have a panel on that. And I said, well, we've had AI panels twice in the last 3 years. And they said, yeah, but aren't you doing any new research on that? I said, yeah, it's a fair point. So at the risk of looking like we're repeating topics, there's been so much development, both in the research here at Purdue, as well as industry embracing the idea of AI and industry engagement in the areas that we thought it would be appropriate, again, with our board's direction to have this panel. So we have been a little bit of a pivot because we had some other things that came up with one of our government-funded projects that pulled my boss, Dongyang Zhu, out of the room, who was going to be moderator. But we're in good hands, and Professor Berkay, Celik, who collaborates near daily with Dongyang on several projects right now, and is also part of our key AI cybersecurity team. So I'm going to turn it over to him for a moment, but since I do still have the microphone, I want to turn, and it was just announced recently that Ananth Grama was named the director of Purdue's Institute for IPI, Institute for Physical AI Application. So we actually asked Ananth to join this. We actually asked Ananth to join this panel before we knew that he was going to have that new position, because we recognized what an AI expert he was. We're glad that the rest of the university also recognized that and named him the director of our sister institute. Berkay?
All right, thank you. So good afternoon, everyone. So we are thrilled to have you here join us for this insightful discussion on intersection between AI and cybersecurity. So this is a very broad topic, but I would like to structure this topic into 3 different broad categories. So basically the good, the bad, and the ugly. Okay. So the good is basically how we leverage artificial intelligence for security applications. This might be for robust object detection and tracking, and even like simpler cases like spam filtering. And the bad is, when we build these systems that rely on machine learning, are they secure? And historically, like if you look at last 10 years, right, adversarial machine learning, they are not. In its simplest form, what can go wrong is you go and modify a type of image or input to the machine learning system and change the output of that system. So we have seen adversaries can make the stop sign, yield sign, or vice versa. And this is an integrity problem. So with the recent advances, we see similar things. Stable diffusion, large language models makes our daily lives much easier. They find opportunities in national critical systems. Even I start seeing, autonomous driving uses some LLM to interpret the physical environment. However, similar to what we have seen 10 years ago in adversarial machine learning, these systems also can be in attack. So there are bad situations, right? Prompt injection attacks that we are seeing, jailbreaking LLMs. Stable diffusion systems create some images that we really don't want to have, right? On the other hand, the third broad category that I categorize is ugly. Even though leveraging machine learning or AI in general for security purposes, for good purposes, right? And then we know the bad purposes. The ugly is this. These systems can also facilitate, from an adversarial perspective, bad actors as well. They can now craft spam that really looks very professional. They can generate a malware code very easily now. So this is the ugly part. So the panel will be structured around these 3, basically, the themes. But before that, I would like to introduce the panelists here. So I would like to start with Tim. So Tim Benedict is a Chief Technology Officer at COMPLiQ. He brings a wealth of industry experience in implementing and cutting-edge cybersecurity solutions to industry. So next, we have Dr. Jing. She's associate professor in electrical and computer engineering department, and her research is focusing on theoretical machine learning with the application of security. Finally, we have Dr. Ananth Grama. He is the Samuel Conte Distinguished Professor of Computer Science, and he's the director of the Purdue Institute for Physical AI. His experience in high-performance computing and data mining provides invaluable insights into the computational aspects of the AI in security. So to structure our conversation, the way that today I would like to do is this. I will give each of the panelists 5 to 8 minutes with the introduction of, but also answer a question regarding an important topic. So, okay, let me check it out really quick. On the road. Okay, we have a backup. Let me use this. Okay, I think you can hear me well now. So let me repeat what I said, so we will go this discussion with these 3 things, the good, bad, and the ugly. But also, I would like to initiate the conversation in their 5-8 minutes conversation. This question, okay? So what is the most significant opportunity or challenge presented by the intersection of AI and cybersecurity today, and why? Thereafter, after we get these opinions, so the audience can ask questions to the panelists. So, Tim, I would like to start with you.
Thank you. So at COMPLiQ, we spent the last 2 years building a SaaS offering that holistically protects the integration of models in private sector and industry. And the biggest challenge that we have found is when we are talking to other organizations, and we spent about 6 months last year speaking to over 200 different organizations with a grassroots campaign outreach. We really wanted to see what was out there. So we chose to speak to CISOs, chief technology officers, and chief information officers. And we found that the chief information security officer was very aware of what the organization was trying to accomplish with AI. However, the risk approach or understanding how they would mitigate or put controls around their AI systems in general was a challenge. They also knew that shadow AI was very pervasive in their organization. This is not the first time that we've seen a shadow technology happen. Cloud as an example 10 or so years ago. But what's happened over the last 2.5 years, realistically, is that AI itself has been democratized. What I mean by democratized is I can now go and with a credit card, or I can go to a technology provider, and I can interact or use a Copilot or an API inferencing point. And that's a very powerful thing. And as you said, LLMs are really moving that adoption and pace. But the biggest challenge is it's a challenge that they're not aware of. It's something that they're not really, how am I going to approach even taking this proliferation of technology? It's a very fractured integration point. So you're going to have problem solving X being solved by this AI system in HR, and then finance is going to have a different view, right? So really what we found is that AI in the private sector is really viewed as a business logic discussion. It's not the AI itself that is the principal piece. It is how is it going to interact with the CRM system? How is it going to help me with my sales elements? And what this does is it creates a very bold challenge of, I've got AI everywhere. I have to understand how I'm going to approach it from a risk perspective. I've got some data governance elements, but that is a narrow focus towards protecting AI. And so what does that challenge look like? So what we decided to really start focusing on is, okay, I can go and I can download a foundational model. I can go to Hugging Face. Again, the democratization and usage of AI. Another aspect of that challenge is it brings a new threat landscape to the system. So if I have a very well-defined SOC and I've got it baselined against the traditional cybersecurity framework, like you said, prompt injections, jailbreak attempts, these newer threat landscapes, which aren't actively mapped into, I would say, traditional security controls, are also a challenge. So if I do have these systems integrated across my enterprise, I potentially have some newer elements of tactics, techniques, and procedures that I may not be able to detect or even be able to integrate holistically. The other challenge is it is not an infrastructure conversation. So I'm not going to come at it from a firewall perspective or an identity system. It is, again, you're talking about this logic being embedded into the application systems themselves. So if I have a guardrail-based approach, how am I going to approach that? I think that the last conversation was very compelling around digital assurance. It's the same element. I don't want to come at it from a one-size-fits-all. I may need some risk in incident response to this system here. I may have a high-risk AI system over here. So what we're looking at is a combination of having to approach it from a cybersecurity perspective, understanding risk and privacy, and potentially governance and compliance, which traditionally are all three different elements now put into one element. And then we have the fragmentation of up and coming legislation that is potentially impacting, design decisions with I would say the EU AI Act might be the golden standard there. We've also heard from our partners that they're using some of that classification and codifying it into those governance and policies. But a lot of organizations already have cybersecurity debt. This is an educational conversation of helping them understand what is out there. And it's really a truly fascinating and foundational conversation. So we are really looking forward to continuing to partner with academia and research and bringing that industry bridge into helping organizations safely protect AI in a guardrail that is appropriate for the system and allowing the use of AI as it needs to be done and allowing it to proliferate as well. That's what we've been seeing over the last 2 years.
Yeah, how it works. All right, so I have some questions to you, or maybe audience can ask some questions, but I would like to first go with the panelists to get their opinions. Maybe Dr. Gao, we can go with you as well.
Sure. Yeah, so I think I will, so my research is actually machine learning, data mining. So some aspects our group has been working on is related to this intersection of AI and security. I like to discuss, maybe answer to that question, like what are the challenges from these aspects, but I will mainly focusing on this good and bad part, maybe the AI for security and like the security for like secure AI models. So for AI I will mainly talk about our research experiences and then like talk about like the future plan kind of. So first of all is AI for security. I think this direction has been going for a long time. We can trace that back to a long time ago. So before, I think a long time ago, like the traditional security systems depend on static rules. But later people find that we can accumulate so much data, right? So we have like network traffic logs, we have those information collected from the system. And then AI-powered models can potentially help us analyze large amounts of data and then detect unusual patterns, suspicious behavior, right? So in the past, we have been working on like, anomaly detection to how to automate the process of detecting anomalous patterns from the data. So my research back then, so we have been working on like how to effectively detect anomalies from streaming data, from data coming from multiple sources. So how can we detect inconsistencies across those sources? And then later, I think that's also partly related to this ugly part, right? So right now, like with those technology developments, we found that there are so much model AI models or like solution, like attackers or hackers, they can utilize to complicate this process. So for one example is this fake information generation, right? Fake videos, fake information on social media, and like they can use all sorts of technologies to generate such fake data to initiate cyber crimes, right? So our research, part of our research back then, so we work on this fake news detection from social media data. So all those tweets, all those like information people publish on social media platforms, can we develop some AI solutions that can tell us like which like piece of information tells us the true information and which is fake, right? And then for that, we developed, back then we developed this multi-model framework that utilize both like image and text information. So it extracts useful signals from both modalities. And then I think another distinguished, interesting feature in that model is we developed some event invariant feature detection. So you know, like we can train our model on some past training data that consists of fake news and then real news events. But the challenge is that those training data are from past events, but we want to make predictions on the future events, right? So we want to extract some event invariant features that can help us achieve that goal, right? So that's like what our research is about. But I think the new challenges in this direction is definitely like the ugly part, right? Because technologies are advancing, and right now, like people use LLMs, use those diffusion models, use these generative capabilities, leverage those capabilities to generate those really something fake, but really looking real, right? So how can we effectively develop effective AI solutions to detect those things, right? So that's actually, I think, one of the major challenges right now. Even for the fake news detection part is still like, I don't think it's solved. It's still very difficult to detect. And then the other angle, a very important angle, is definitely like how to secure AI models right now. So for AI models with the development of like deep learning models, these LLMs, we definitely see the transformative impacts of those models. But at the same time, they also bring so much challenges for securing those solutions. So for that, we have worked on, actually I had the pleasure of discussing this data poisoning attacks on this symposium last year. So we work, so you know, like in the perfect world, right? So if we train a machine learning model, we have our training data is clean, is perfect. You train a machine learning model and then use the machine learning model to make predictions on testing data, right? Future data. But in reality, we have attackers who may want to maliciously like manipulate the model, manipulate the output. So there are like test phase attacks, right? So the attacker just change the objects a little bit, change like patch something on the stop sign, right? That's a example, or like just change the image a little bit. So it's very unnoticeable changes. But can evade the model, like the model will predict something completely different. So that's test phase attack. But our research focuses on the training phase attack, or we call data poisoning attacks. So how to manipulate the training data and then so that we can manipulate the future output on the test data. So for that, we have developed various data poisoning attacks strategies. So basically exploit the vulnerabilities of those machine learning models. But right now, you know, like with large language model, we also have these new challenges, right? So all those like jailbreak attacks, so those kind of attacks is how to make LLM output something harmful, right? So people have been studying that. So there are definitely vulnerabilities out there, and then like people are still exploiting it. So it's still relatively new, like how to fully exploit the vulnerabilities there. I think that's also a challenge. And then another dimension is like privacy leakage attack, right? So one of our recent research is actually on this copyright compliance or copyright leakage out of LLM output. So for LLM, we know it's actually trained on so many corpus, like large corpus, so many data. And then people find that actually it's often also some copyright protected materials. And there are jailbreak attacks like specifically designed for this copyright attack. And then how can we understand the degree of attacks, how like under what scenarios LLM will output copyrighted materials. So what defense mechanism we can use to protect LLM from outputting copyright materials. So that's one of our research focuses right now. But besides that, there are like lots of like jailbreak attacks ongoing, right? So how to, in general, like how to exploit LLM to output something that it shouldn't output, right? So that's also a challenge out there. So for this part, I think I mainly talk from the attacker point of view, but definitely defense is another like very important aspect. So basically like based on all those attacks, like basically people need to think about their design choices when they design AI models. So keep in mind that there are hackers out there exploring all those vulnerabilities. I think that's also a very important direction.
Thank you so much. It was a nice summary. So I'm teaching a class which is called Security Analytics. So in this class, basically what we do is we try to understand how we can leverage AI for security applications. And also we look at the security of the AI systems as well. And in recent years, what I see is, students are really interested in learning in these topics. But from our perspective, the biggest challenge is this. There are a lot of algorithms implemented in ML, to follow them and then also to follow all these attacks, keep the syllabus up to date becomes very challenging. But what I feel is, like we need to have a workforce expertise in this domain because not only commodity systems, what national, I would say critical infrastructure also integrates now AI algorithms as well. Okay. So lastly, we would like to get the Dr. Grama's perspective on this topic.
You guys hear me? Can you guys hear me? Maybe I'll keep. I'll keep. Does that work? Does that work? Hello, 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 hello. Sorry about that, guys. So my name is Ananth Grama. I've been here a very long time. I've probably been at Purdue longer than most people that I meet anymore. So I've been here for 29 years. And over 29 years, you see a lot of trends go by. And so as a group, we're a very large group. We work on a diversity of problems. We work on a lot of problems in Gen AI, on fine tuning, on LLMs, things like that. We also work on learning theory models, learning at adversarial environments, learning from adversarial data, characterizing hallucination, defining hallucination. But I don't want to talk about any of that because those are in papers and you can always read those things. So my perspective is if you're going to give me 20 minutes of your life, I want to leave you with some thoughts perhaps that you would not have thought of by yourselves. Maybe I'll fail, but I'll at least try and do that. So philosophically, I think there are two kinds of problems or two kinds of solutions. You either want to do things quick or you want to do things right. And just about everything we do falls on this spectrum of doing things quick or doing things right. And AI squarely falls in the regime of doing things quick. We are half-assing everything. I apologize if I used a bad word. We are doing things not right in AI. We're trying to do things as quickly as possible because we see massive upsides to AI and AI deployment. And I liken this to where we were at perhaps in IoTs and CPS about 10, 15 years back. We saw great value and potential in putting sensors on everything, controllers on everything and intelligent control elements on everything. And now you fast forward 10 years, 15 years out, we have massive security challenges with all of CPS and IoT things. And in my opinion, what we're doing with AI today and deploying AI elements all over the place are going to lead to an order of magnitude worse problems 5, 10 years out, mostly because we're doing things quick, not doing things right. And I think we all recognize this is a major challenge. We need to get this right. So let me make some observations, and maybe you have all come to these epiphanies yourself, but maybe some of it will find it new. So the first thing is we sort of assume that AI systems work in closed worlds. In other words, give me a bunch of data, I'm going to learn something from it, and I'm going to do something for you. The world is never closed. Any AI system that you deploy in any real environment works in an environment that is surrounded by other systems, perhaps other AI systems. So what do I mean by that? So you are a major manufacturer, you're trying to make your supply chains more robust, you're trying to optimize for your ROIs, things like that. Now understand that there's somebody upstream of you and somebody downstream of you who's playing that same game. And they have their own AI systems that are doing the same thing. So an AI system almost certainly will not exist in a closed world. It has to exist in context. And what that means is anything that we optimize for an AI system, any loss function, all of the trivial things we think about right now will almost certainly fail because somebody is sitting on the other side who's optimizing a loss function that probably works against your loss function. And so you must always think of AI systems working in a context, which almost immediately gets you into a much more complicated set of problems. Right now we think of optimizing systems. You will start thinking about minimax optimizing systems. In other words, assuming a worst case input and output, how do I optimize my system? Okay? So the way we think of at least critical AI systems will fundamentally change. That is my first observation. And maybe not all AI systems, but certainly for a broad class of critical AI systems, you have to consider context. AI does not live in closed worlds, will not live in closed worlds. The second thing, and some of you might have heard me talk about this, at least maybe a handful of you. Today, AI systems work primarily for a human interface. So you look at your GPT 4.5, Cloud, Llama, what have you. The target audience for these systems is a human. Okay, so it's AI and human. And humans have a very, very limited interface. If you think of what goes in and out of your head, it is exceptionally limited. And so this was an epiphany I had a few years back. The amount of information that I can get out is literally through speech. That is horribly low bandwidth. It is less than a kilobit per second. The amount of information that I'm getting in is perhaps through speech and some audio-visual, multimedia data, but I really have very limited comprehension and attention even to that. So the amount of data that my brain is capable of taking in and putting out is at best maybe a megabit per second going in and maybe a kilobit per second going out. That is incredibly small. And that entire interface is based on language. And thus we think of large language models and language encoder, decoder architectures, things like that. Our entire AI system, I shouldn't say entire, but a significant fraction of it is based with language as a primary representation. Systems don't use language. Your IoT system doesn't work on a language. It uses protocols. It uses, your sensors are much richer. It's not a kilobit of data going in or coming out. So the entire way we think about these AI systems has to change. LLM is generation 0 of AI models. Yes, it'll last for another 5 years, and in 7 years, we'll look back and laugh at ourselves going like, we thought that was AI at some point, okay? Because systems are much richer than language, so systems will change. The third thing is any critical deployment has to be verified. And we know verification, we understand verification. Verification is hard, verification doesn't scale. And the connectionist mode of AI that we work in today, think neural networks. I am old enough, and maybe some others are as well, but traditionally, if you thought of AI in the mid-'80s, this is not what AI was. AI was based on reasoning, and AI was based on logic. And some of you may have heard of things like Prolog and Lisp and reasoning and rules of inference. Right now, we mostly think of AI as neural networks. Verifying neural networks is next to impossible, but for a small class of neural networks. So almost immediately you get into this regime of conservative mixed integer programs, and forget 80 billion weights. You won't even verify anything that's got 1,000 weights in such a neural network. So you're asking yourself the question, what do you give up? Do you give up verifiability or do you give up large models? And in my opinion, if you look at verifiability, it almost comes down to two concepts: composition and modularity. You have to be able to modularize systems into relatively small pieces whose behavior you can reason about. And you have to be able to compose such small systems into larger systems whose aggregate behavior you can reason about. So what do I mean by that? So think of how you would deploy AI in your own enterprises, what have you. It's not one mother in the sky AI system that's going to collect all the data and reason about it. That is a very limited use case for AI. So AI systems will likely exist at the edge, where you're making decisions at the edge. They will exist somewhere close to the core. They will exist at the core. And all of these have to reason in different ways in response to their own stimulus. But more importantly, you have to reason about the behavior of that integrated whole. And that is a much, much harder problem. We're not talking verifying one AI model. We're talking about the verification of a composition of a large number of federated AI models, which might themselves have stochastically defined behaviors. Much, much harder problems. So where'd we get that? So our representations have to change. Our interfaces have to change because language is not the right interface. Our formulations have to change because AI doesn't live in closed worlds. Our verification models have to change, mostly because we can only verify small things and we can verify compositions. Our deployment settings have to change because there will be no single AI unit that's going to run everything. And finally, there would be absolutely other problems which are based on small data and small models and small resources and real-time response, which current environment absolutely does not do. Okay, so in my opinion, I wouldn't even think of what we are doing as prime time anywhere close to it. We are at version 0.0 of where we're at, and 5-10 years out, if we continue along this path, we will end up exposing massive attack surfaces and huge problems, or we end up starting to solve the real problems as they relate to these domains. So it's my 2 cents worth. I'm sure you have different opinions, and I look forward to your questions.
Right. Thank you so much. Really appreciate all the panelists for their opinions and for the great opening. So now I will move into the question and answers portion of the panel. Please raise your hand and I call you on.
Hi, panel. Thank you very much for your time and for your insights on the intersection between AI and cybersecurity. I was wondering how, with the way social engineering tactics are going these days, especially in the areas of like searching through social media, and the amount of data that is available about the individual that is out there, the amount of that is being sold by social media companies, the amount that's being collected through cookies and through various points of data input. How can AI manipulate that data to be used against both the individual and a large scale organization, and as well, how can the cybersecurity professionals stay ahead of that advancement and counteract it?
Yeah, I'll take that. Reconnaissance is not a new technique for starting a multi-staged attack. What I think, I agree with your thoughts on AI. This is the ground zero. LLMs are a jump start to smaller, closer models. Edge compute is always going to see that. We've seen trends, and especially with IoT and the marriage of those things, which is why I completely agree with the physical AI aspect. But what we're talking about from a reconnaissance perspective, it gets a little different. Since LLMs and the language interface is the primary, I can do much more advanced reconnaissance if I'm hitting a chatbot and doing prompt engineering, and if it is connected to other elements, and a lot of the stuff that we're talking about, these are real exploits. Now, it doesn't necessarily mean that I'm going to get an evasion attack immediately. I might have to do a multi-stage attack, but reconnaissance is a very real issue. And oftentimes when we're doing red teaming, not just pen testing, I'm talking about red teaming where we're actively doing a reconnaissance stage. We try to help organizations at least strengthen the ability to not let scraping happen on a website, understand how to do policy user training to not post elements that could lead to that reconnaissance, and especially with the agent-based approach or the chatbot-based approach, which has really high potential of doing wonderful things, especially the autonomous elements. It can be a big challenge. So this is where, again, the intersection of cybersecurity and AI, we're not changing our approaches. Just because it's a new threat landscape doesn't mean that our practices of red teaming and whatnot are ineffective. As a matter of fact, red teaming is one of the most effective ways to continually ensure that your attack patterns are there. And beyond reconnaissance, you really need to, like, again, going back to those guardrails, put the appropriate measure in. If you want to have something that can detect a basic prompt injection, somebody might do something as simple as ignore my last response. That could be a common indicator that somebody is, looking at your elements. You could look at things like an indirect prompt injection attempt, and they're attempting to do a known hallucination attempt, so that it is coming from, oh, this model thinks that this is not an adversarial IP address. So again, going back to user awareness training, logical guardrails, human in the loop elements, and especially red teaming approaches are very effective against the reconnaissance pieces.
So I think I will maybe talk more about the privacy part. So I teach the introduction to data mining. And then in my course, I think there is one section on recommendation. So I always tell the students stories about how those e-commerce websites use your web browsing behavior, your purchase behavior to make recommendations. Like Facebook recommend new friends, recommend news, advertisement, but the underlying mechanism is all to use individual data, right? So use all those data contributed by individuals and then make those recommendations. And then I think here, there are actually two aspects. So first of all, definitely there are some privacy concerns out there because all those behaviors are actually exposed, right? And then, but the other side, those services are actually based on individual data. If there are no data available, and then those services may not be available to you. And I think there is some discussion on whether we can maybe pricing the model, pricing the data. For example, maybe some users are okay with exposing some personal data, and then you can treat your data with better services. And then some users are more conservative, and then maybe you just get some basic service if you don't want to expose your data, right? But right now, I think that kind of pricing model is still not there yet, but that could be a potential direction, right? So how can we better trade off those two parts, services versus privacy? And then another aspect is basically the policy, right? So even though the service is based on mining those large amounts of data, and then some users are okay with some privacy leakage, but we have to make sure that the policy, those privacy policy, is followed. But how can we integrate that into the model? So how can we make sure those policies are followed, right? So that's also a very, I think, important direction that people definitely need to investigate.
Wonderful answers. Let me give you a somewhat more theoretical perspective on your question. I think a profoundly important question, and also one that we need to be a little careful in how we implement and answer the question. So let me give you some examples of what you might have asked. So in the whole privacy world, there's this thing called label privacy, for example. So let's say you have an set of attributes X, you're trying to predict a label Y. and label Y is sensitive. So we've all seen problems like this where you will introduce some noise, differential privacy or whatever noise model you want to use into Y, okay? And then you ask yourself the question, can I learn a model that maps X to Y from your privatized data? I can theoretically show you that very quickly I can undo your privacy. I can prove to you that differential label privacy does not work because the learning process undoes your label privacy. Likewise, I can also prove to you that if you add noise to data and you only let me see noisy data, I can actually fit an optimal model to denoise data. So basically, I don't need to know the actual data. My model will find it for me under relatively weak assumptions that the noise model is well separated from the data distribution, things like that. So we can do all of that quite easily. And it's extremely important to understand that those solutions exist. So we can't hack ourselves out of these problems. Likewise, I think the issue of hallucinations came up. You have to even define hallucinations right before you say, how do I trick a model into a hallucination? So, I mean, if I were to poll what is a hallucination, most of you would say a hallucination is the output of a generative model, which is not true. But we don't know what truth is. So how can you say something is not true when you don't have the truth set? So then you go like, okay, well, maybe hallucination is not the absence of truth, but maybe hallucination is something that is not supported in training data. Well, that's a very weak definition as well, because then you assume that the generative model can only generate something that's in training data, which means that it's basically information retrieval. It's not generating anything new. So just defining hallucination formally is a hard problem. And then once you've done that, we can actually show that any finite VC dimension model is bound to hallucinate unless you do some other things. So that's my plug for being able to reason about these models, because unless you can reason about where your vulnerabilities are, anything that you patch them up with is simply a patch. Somebody else will break it at some point.
Is there a follow-up?
No, my question is not a follow-up.
So you want to ask another question? Yeah,
Yes.
please go ahead.
So, Ananth, you mentioned about the importance of verification of neural network models. So one approach could be that you break them down into smaller models and verify these smaller models, like a mixture of experts, and verify the federation. But that has also run into some trouble currently. Another approach could be just you thoroughly test the neurons, neuronal test coverage. Are you hinting that these are promising paths, or we should throw out the neural network architecture and go back to the drawing board?
Again, I might say something that many of you might disagree with, but really when you're trying to validate something in an input space of 1 billion dimensions and a weight space of 80 billion with strong connectivity. So let's say you have a neural network with dense layers that are connected across each other. The dimensionality in which you're trying to reason is so high that either you will be so conservative in your proofs. In other words, these are all decision surfaces. You map something very conservatively in that high dimension, in that decision surface, and you will be able to reason in either a very conservative way, or you very quickly run out of the complexity and the hardness of these problems. So I would be willing to go out on a limb and say that large, densely connected neural networks are almost impossible to verify using current techniques. You almost have to, it's got to be something that we fundamentally do not understand in verification that has to come through. Otherwise, these are not verifiable. Now, of course, people will still try to verify them. You can sample the space, but so by the way, this is my distinguished colleague, Professor Sarabakchi, for everybody else. So we know this. You cannot even sample a 100-dimensional space, let alone a billion-dimensional space. So we cannot strongly sample these spaces in any meaningful way to reason through sampling. So where does that leave us with your question of neural networks? I will still argue that dense neural networks cannot be absolutely verified. You might be able to get a probabilistic bound on their performance, but that probabilistic bound also is so dependent on the dimensionality of your problem and your model space that getting a strong probabilistic bound on large models is impossible to the point where you would not use it for controlling a nuclear reactor. That's sort of my perspective.
So there is a trend, right? We've moved from fully connected layers to the CNNs, which are less dense. So you see some hope in that trajectory.
that we should not be building dense models because dense models are so data hungry that for anything that is in the real world and perhaps in non-stationary distributions where you have to sense and shift your models in real time, you will never have the amount of data to train a densely connected large model to the point where it can sense distribution shifts. Because remember, as a distribution shifts, unless you can converge, you do not converge your model either. And if a distribution is continually moving, you will never converge the model. So I would argue that for just about any non-trivial critical applications, as you say, we should not be using dense models expecting any verifiability.
Thank you. So we have time. We can get one or two questions. Okay, we have one more question only. Okay.
So with LLMs becoming more advanced and this kind of thing, to what extent are LLMs able to, or machine learning models able to reason? Like, for example, if I ask a model to only do something if some condition is met, it will do that for me. But if I then ask it to pretend to be somebody else where that rule no longer exists, then suddenly it will avoid a rule which I've given it previously. So is there any way that we're aware of, or do we even know if it's possible to give logic and reasoning to such models that they'll actually keep, or is everything kind of just in flux?
My perspective, and people can disagree with me, which is often the case. So irrespective of what claims you see from current large LLMs, I do not believe LLMs can non-trivially reason with any non-trivial logic. And let me be specific by what I mean by that. So, I mean, we all understand the simple logics, the propositional logics, the predicate logics, and these are trivial. But real world logic is a lot more complicated than that, right? So, and real world inference is a lot more complicated than that. I think it was one of these funny anecdotes that I saw. This might have been earlier, they might have fixed this. If you ask an LLM a question, a wolf and a goat and a fisherman trying to cross the river in a boat, how should you do it? And you get some answer, but then you say, if you just ask the question, a fisherman and a goat are trying to cross the river, and you get this really stupid answer. It'll go, come back with an empty boat, go back again, come back again. Because it's simply trying to pattern match these things. So there's no reasoning in these things. And I don't care how much you say that, okay, well, I'm going to understand that you're trying to include a reasoning question in there, so I'll be able to do some math, or maybe I'll even get some induction in there. These are hacks. These systems don't fundamentally reason. There is not a well-characterized logic. There's not a well-characterized set of rules of inference that is sitting underneath these things. So these are profoundly hard problems. They're not solved right now. And I really do believe that these systems need to evolve in that direction. Now, of course, there are some very simple efforts at can we have deep satisfiability frameworks? In other words, can you use neural networks to solve satisfiability? Yes, you can use neural networks to solve satisfiability to some extent, and maybe they will even improve on the best SAT solvers that you have today. But that is very, very far cry from being able to reason in the way that humans reason in a stochastic environment. I just do not believe that current LLMs are anywhere close to that.
I agree. I'll give my perspective. Before I walked up here, I wanted to make sure it was still true. I asked ChatGPT if it wanted to play rock, paper, scissors. It said yes. They went first and gave me rock. So I said paper. It said, congrats, you win. That was great. And I want to go back to, from an industry perspective, LLMs are an enabler. And I think that what's happening in folks that are not in high academia, like where you all sit, is AI is this magical thing that is changing, right? And it's not uncommon, but it is something that does need to be demystified. Where I think a logical approach could be is, if I want an AI to be able to do something specifically, then approach it architecturally in the way that it's meant to be approached. If you want an agent-based approach and you have it wanting to do something very specific, that's a great way to start with a realistic, real-world, proven integration potential. But I do agree that reasoning and other elements we're years away from that. But it doesn't stop us from being able to at least architecturally move into those spaces. And I gave a security seminar last week. We talked about the importance of architecture and applying those elements. AI, again, is going to do a lot of things for us, but if we don't treat it with realistic use case intention and integration points, we're just gonna, like, I agree, 800 billion parameter LLM sitting in the middle of a huge, enterprise software system it's great, but it'll do some stuff. But we just got to get more realistic about how we can do agentic AI agents, hybrid chatbots, RAG-based deployments. These are the elements that I really think that we should be focused on to get to that point of reasoning and high use case value.
Yeah, so I also agree. I think this is actually a very a popular research direction right now, like improve the reasoning capabilities of LLMs. But I think current solutions are still maybe like patches, so people should still think out of the box. I think some directions people have explored, like using some chain of thoughts kind of idea, like break the complex tasks into several steps, and then go along the path to do the reasoning. And some other ideas like more domain specific. So for example, if a question is related to certain domains, so can we leverage knowledge from that domain to help with the answering of that question? So for example, like math reasoning, so can we use calculator or some other tools to help answer that question? So often people show that if you just use LLM to answer math questions, so it may not work that well, but if you use some outside tools that give you better answers. And then like people just employ these different ways to help improve the reasoning, including like more focused models, like deriving several agents that focus on particular aspects. And then we can design some routing mechanism to route the question to the appropriate agent and so on. So I think there are ideas out there, but still there's so much like opportunities and then challenges. So definitely it's not solved yet.
Great.
Yes. So regarding the question, I would like to also add a couple of sentences based on my experience. When I initially used a large language model or any kind of diffusion model, the results are not expected. But what I see is over, maybe 1 or 2 years, they are trying to once improve the model itself and interface the model with other systems, such as the calculator or other machine learning models. Or whenever you give a prompt, they try to understand the prompt in a better way and try to create a kind of, sequence of things, reasoning capabilities, making that small prompt very big prompt. And then again, using sometimes online search, maybe using another LLM as a judge. So they make this kind of, and then the results, to me, what I see is getting better. That's for that reason, like we see like different products, not only chatbots, but agents. We also see, kind of like a deep search. So they can do like deep search. You just give it and then just goes online and then brings back and then sometimes get feedbacks from the human as well when they are confused. But I don't think, the level of the human is there yet. So I mean, but there are some improvements. So we can get one more question. All right, so we have a last question over there. So the mic is coming up.
Very relevant because I know it was just released. It was the Gemini 2.5 Pro, which I know it claims that it has enhanced reasoning and logical. And from what I've seen, all that really means is that it actually shows you that breakdown that I think you were just alluding to, where it shows you the interpretation of the prompt. And it's what's nice is that you can actually see how it's interpreting what you're saying, and then maybe you could even take a different approach to tweak your prompt. But I was just curious if you've used that and if you had any particular thoughts about that.
So again, what is the question again? Can you
Just the latest Gemini 2.5 Pro, which claims to have the
Yes,
capability
yes,
of
we got it.
enhanced reasoning and logic. And I think you were maybe just answered my question for me, talking about how we're kind of going in that direction. I think they call it the chain of thought, like a COT.
True, yes.
Yeah.
I mean, that exists like recently. I mean, I think they know the problem, right? The reasoning capabilities is not there, and try to make this with some chain of thought, as you said, right? And sometimes whenever you ask a prompt, for instance, so they want to keep the human not in the loop, they ask another LLM, can you please explain me what user means here? And they can even use your search history and like maybe like so previous prompts in order to make that process, right? But at the end of the day, I think the fundamental problem is still there. That's what I do. True, true, I agree. So any other opinions on this from the panelists?
Yeah, one recommendation that we give our organizations is try prompt engineering against multiple models at once and see what comes back. And when one advancement in one of the major hyperscalers or whatnot happens, you can see that it has a little bit more accuracy. And again, it's a leap forward, so we should appreciate that. But again, prompt engineering itself is a very powerful core skill set that I encourage everybody to learn, and always test the efficacy of the model and the different elements. We've just developed a very simple interface where you have one chat and it hits 5 or 6 different model types, and you can see what each one is doing. And if one is more accurate at that time, then you can use that for whatever your use case or your element is. But always verify that, and always try to see that. I don't disagree from our side. I don't think anybody's really believing the hype. Remember, these folks are out there from a capitalistic perspective trying to get more subscriptions. That is the American way. It's not a bad thing that they're out there trying to do that, but real innovation is going to come from institutions like this. I think you guys have a very large opportunity to advance those elements and help define that as well.
Another?
I haven't tried that model yet, but I think from what you just described, it seems like it's more towards the direction of like improving the transparency, interpretation kind of thing. I think that's definitely very helpful, but I don't think it's really like inherently enhance the reasoning capabilities yet. So not there yet.
All right, I think we are running over time. I will not get any other questions. So thank you so much for the fascinating discussion and exploring the intersection between AI and cybersecurity. Thank you for our panelists, and also for sharing their valuable insights, and for audience to questions. So this is a very important topic, and I don't think like 1 hour is sufficient for this. I hope everybody has at least a direction to explore and then check the possibilities and opportunities in this domain. Thank you so much.
Thank you.